Adding outlines can be a great way to add a graphic impact to your 3D scenes in Godot. I've put together a project that does just that. It takes the viewport's normal and depth buffers, processes them through a filter, and produces outlined outputs just like this. Stick around and I'll show you how you can add the same effect to your scene. First, you can hop over to the Github page to download the project. You'll only need one file from it, the edge detector sobel.gd shader. It's in the Godot shaders directory right there. Once you've downloaded it, you can add it to your project, and you'll notice there are some other files in this project too. They're just examples that give you a demonstration of how to use the shader. So if you'd like to see the shader in action before you add it to your own project, just download this project and you can see what I've done with it. To set up the outliner, start by creating a new quad mesh with the default settings. I'm going to start by creating a mesh instance 3D and then adding a quad mesh to it. You can see that's just a regular flat plane there. And now we're going to add our shader to this by going to Geometry, Material Override. Let's create a new shader material. Then we can click down, and under Shader, we're going to do Quick Load. Then we're going to pick that Edge Detector Sobel GD shader. And you can see right away, if you look through that, you can see it's starting to work. Now, it doesn't work if you look at it through this direction, but if you look at it through this direction, you can see it has already started working. And if we even turn it around like that, you can see it's already doing that outline. Already doing that outlining. Let's bring that back to the middle there. Now, this can be fine if you want this magic window effect, and you can put this on whatever object you want, but you probably want it to fill the entire viewport. So let's go back here and undo the transform to set this right back to the middle again. Okay, so back to the default transform. So in order to map this to the default viewport, we can open up the shader parameters and click Map Quad to Viewport. And now, even though you can still see the mesh here outlined, we have the vertex shader that is manipulating these vertices so that they fill the viewport perfectly. In fact, if we open the shader editor and we click on the shader, you can see that code right here in the vertex shader. When this is set to true, we're doing this special equation here, which is going to automatically map the quad to the entire viewport. Now there's two more things you need to do. We're going to increment the render priority. This is to make sure that this viewport is drawn after everything else in the scene. Otherwise, there's a chance that some of these things might not be drawn until after this shape is drawn, which means they're not going to be outlined. The other thing we're going to need to do is set the custom axis aligned bounding box to something huge. Now look what happens when I am in the scene, and if I go past the object here, if you see how that clicked off, the reason why that happened is I moved past the quad mesh, and that went behind us, and when it went behind us, that got clipped out of bounds, which automatically turns it off. Well, in order to avoid that, we can just set a really big bounding box on this. Let's do negative 500,000, and let's make the width 1 million. And you can see that even when I go past it now, it still stays on. So this still has a problem. If you happen to go outside of this million-meter wide bounding box, it will still click off. You probably don't want that, but chances are your scene is going to be very much smaller than this huge bounding box. Okay, once you have everything set up, you're probably going to want to adjust these to get the effect that you want. First of all, the line color here will change the color of the outline you're drawing. If you set that down to black, you can see you get a nice black outline. The background color affects everything that is not the line. So if we turn the alpha up, you can see we now have that black on white drawing, like ink on a background. You can change that to whatever color you want. You can make the background red if you want. You can change the line color to, orange maybe. Sort of a neat effect there. Just set it to whatever you want to get the outline effect that you need. Okay, let's set those back to the defaults. Next up, we have detect type, and you can see we have three options here. Now, in order to explain in a little bit more detail how this shader works, Godot draws everything to a viewport buffer, and when you're in forward plus mode, like we are now, this is important. This won't work properly if you're in one of the other modes. But in forward plus mode, it draws a special buffer that contains normal information, which means which direction the surface of the shape is pointing, and it also contains depth information, meaning how far away it is from you. And then it's going to take that information and push it through a Sobel filter, which is a fancy way of saying it's a special mathematical filter that detects differences. So if you have like nice smooth areas, like you can see how the nice smooth curved edge of the rabbit here, because this is changing very slowly when it comes to direction and depth, it's going to have a very low value in the Sobel filter, which means it's going to get sorted away. It's going to have low value, so there's not going to be a line there. Where there is a big change, like where you have the rabbit sort of comes around here, and then there's a sharp break, and then suddenly it's going in a completely new direction down here, that's going to have a very high value on the Sobel filter, so that is how it knows to put a line there. Now, what exactly is it measuring? Well, it is looking for the normal data, which is which direction the surface is pointing, and it's looking for the depth data, which is looking for overlaps. Now, if we set this down here to depth only, you can see that it is only taking overlaps into account. And right now, there's not much overlap. The overlap is the distant background and the edge of the shape here. And you can see we've almost entirely lost the inner little lines there. And you can see that whenever we have the rabbit sort of overlapping the dinosaur in the background, there's a nice clear outline there where the rabbit outlines the dinosaur. But for a much more subtle depth, like its neck and its body here, that isn't wide enough to be able to tell the difference. Now you can play around with depth cutoff to make that more or less precise, but you're not going to get a whole lot out of the depth filter, which is why we have the normal filter, which is really good at detecting changes in surface direction. Now you can see we have that little line that comes under the chin here and comes down over the foot, and on the dinosaur you can see it even more clearly. You can see all those inner lines where the surface is undulating back and forth. And of course you can combine them both together with combined, which just sort of adds the two together, so you get that nice blocky outline around the shape, and you also get the inner lines that come from the normal filter. Now, the trouble is that the depth filter it works really nice like this, where you have a nice clear break between your shape and the background. It works a little bit less well in scenes where you have these long planes on the ground and sometimes on walls and ceilings that recede slowly into the background. So it's a lot harder. Sometimes the depth it produces artifacts you don't like in that situation. So that's why you have these options. So you can you can use one, you can use the other, or you can use both, whatever you feel like, in order to get the effect you want. Because sometimes you might want to turn off the depth and go with normal only, depending on exactly how your scene is working. All right, that was a long-winded explanation. Let's see, map quad to viewport, we already showed you that. If you click that off, then you're only getting the effect in the viewport itself. If you turn that back on, now this expects you to use the default 1x1 quad mesh. Turn that on, and that will automatically map that to fill the entire viewport. Okay, next up we have the kernel radius. Now this sort of gets into the math of how the filter works. Basically, you can think of the Sobel filter as a small matrix, and this tells you sort of the half width of the matrix. So with a kernel radius of 1, this is the smallest possible radius. This basically gives you a 3x3 square. If we go up 1, you can see we're now doing a 5x5 square. That's basically this times 2 plus 1. If we click that up again, you can see we're doing a 7x7. And as that radius goes up, you can see we get a thicker and thicker line. And you can also see it's getting a little bit blurrier because it's using sort of a soft filter in order to be able to just check the area around that 1 pixel that we're examining. Now that might be a little bit too blurry for you, which is why we have the cutoffs down here. So the normal cutoff is going to tell you at what point it's going to start taking those difference values into effect. You can sort of think of this as sort of the middle of where the line is going to be, and the cutoff radius is the sharpness. So if you put that up, that's going to make it very blurry. If you bring it down, that's going to make it very sharp. So often 0 is exactly what you want. That's going to give you a very bold graphic line. You can play with the normal cutoff to make that a little bit thicker or a little bit thinner. And of course, you can just bring the radius back down. No need to make the radius bigger than it needs to be. That's just going to make the filter run slower, and it's also going to make it a little bit blurrier. So I think that looks good. But that's the normal options. Let's also go with the depth options. We switch over here to depth only. You can see we have the same effect with the kernel radius. Let's leave that as a 3, and just like with the normal, you can change how much the depth is affecting things, and you can also change how sharp it is. So let's put that one down at a 0 too. And so for these settings, it actually does kind of work with these two models here. But again, it's gonna, let's put that back to combined. And yeah, let's bring that down, bring that up. Anyhow, you can just play around with it until you get the effect that you want. Here's an example of a scene with the filter applied to it, and you can see the nice black bold outline on all our different shapes here. It even works on partially transparent shapes like these leaves here. You'll notice that you have to set the depth cutoff pretty high, otherwise you can get some bad artifacts on that. Yeah, if the default of 0.5 is not going to work on a scene like this. So just put that up to push it into the background. That way you're only going to get that outline on objects that are pretty far in the distance, or you can just skip it completely and go with the pure normal approach. Either way, you're just going to have to play around with the settings to get the effect you want. And this is the fun part where you just go wild with your imagination. Anyhow, that's the shader. It acts on the entire buffer at once. Godot still has a lot of restrictions on how you can build your rendering pipeline, but this should give you a neat way to add a bit of graphic design to your scene. Anyhow, I hope you like this, and drop me a like or a comment below if you found it useful. Thanks for watching.